Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right, welcome. Happy Path Programming. It's been a little while.
It has.
I was traveling a lot.
Lots of traveling.
Spent some time on the river.
Yes.
And so it's been good, but it's beautiful spring in Crested Butte. We don't have any conferences or retreats or anything coming up to announce. So
not really. No.
Yeah. So just normal life. Here we go.
Mm-hmm.
Yeah.
Yes.
Well, today we've got a good one. So we've got Szymon, who created an AI native programming language, and we've been diving into this whole new area of new languages emerging that are really centered around making the AI more efficient, work better. The thing that is really interesting for me about Aver is that it couples a lot of things that we're interested in, like effect systems, but then also adds into it this like validation side, which I'm really interested in because I think as Aver says right on the website, it's easy for the AI to write the code, but then how do you validate the code? How do you validate that what it wrote was what you intended?
Right. Which is ultimately all we ever care about in a piece of software. Does it do what we want it to do?
Yeah.
Yeah. And how it gets there is, yeah. But I'm also fascinated with this, the fact that you have trimmed out all of the, I would call them the human affordances in a language, which I wasn't even really conscious of. But my understanding is that Aver says, all right, if we are doing any sort of looping, we'll use recursion. If we're doing any sort of decision making, we use pattern matching. And I'm not sure about this, but is all values immutable? Or is that?
Yes.
Okay,
it doesn't seem so on surface, but yeah, it's fully
so you're
immutable.
making all the values. So basically all of those extra features, we realize, those are just for people. And this was just an experience that I had, because I had a set of examples that I was trying in different languages, and I was having the AI generate the code for these examples. And it seemed to me like it did the Aver version faster. And I'm thinking, well, maybe because it doesn't have as many choices to make. It's not looking at, should I use a for or whatever? It just goes,
Here is the way.
There's one way to do these things. So is that?
Yeah, maybe give us the just high level. What is Aver, and what were your design principles?
What's your philosophy?
So like Aver is language meant for AI to write code, but that's not the only thing, because my assumption was that like writing code becomes cheap and becomes even cheaper now. Like AI is doing that. You don't need a lot of sugar, like syntactic sugar, because AI can manage on its own. We don't need all the stuff.
We added the syntactic sugar for the humans, and
the syntactic sugar was meant for humans, but there is like the twist to that, which I think is very important in Aver, is that this sugar, it's not really meant even for AI to have only one choice, limiting choices, because that's also a valid like design thing, yeah. But it's more like it's limiting the surface you have to review what was written in Aver later. So there is like minimal.
So enabling
things
the human to also review quickly and not have to understand, complex type system things and other,
really
why did it use a for loop here versus recursion? And
exactly, why do I have ifs here and there, or maybe like ternary operators and stuff? Like I can write this all with match. I can match on values. I can match like some types or whatever. And it's just one thing. There is one keyword, but like I didn't want to minimize keyword. That was not my goal really. I wanted to make it really easy to review. And I don't know if you have managed to see, but I I've added a lot of these intent layers to it. So you have like every function which is not trivial, and that's like not more than one line, maybe, let's say. It has to have like this glorified command, let's say, which says what it does really. And all the functions which are not pure have this kind of effects attached to it. And also we have, like I have, decision blocks which are built into language. So something like ADRs. I have chosen this and not that. And those can also point
ADR,
to...
you mean architectural design record?
Yes.
Okay.
Yes. So those are decisions blocks in Aver. And you can basically say, these dates and this person has chosen, or this AI has chosen this and not that, and point to specific symbols in the program. So it's like checked later that the function you're referring to, it's still there, it hasn't disappeared or something.
So things that in the past would have just gone into comments, maybe, to explain why a particular design
or maybe
decision
they're rotting
made
somewhere on Confluence, because that's what I've usually seen, as a software engineer.
Yeah. And so being able to have a record of those decisions that's in the code and actually is code is
code-ish. Yeah, it's not maybe like fully, you can't have a function in there, like function doing something, but you can point to stuff. Yeah.
So that you can cross-reference things so that those decisions don't go out of date and stale because it was just in a comment or something somewhere. It actually gets validated against the type system.
So can you build more sophisticated types?
Not really. Types are really simple in Aver. You have generics, but in a sense that you can have a list of whatever, and you can have a map of lists of whatever, etc. But you don't have like generic functions with your types. That's impossible. So here you have 2 or 3 functions for something, because that's not yet supported. I'm not fully against that, but there is argument not to have it. The language is really simple on many levels, and adding generics, it doesn't feel like something I will do soon.
Yeah. But you do have some more advanced type system things, like you have value dependent types. Is that accurate? With really. like constructor assertions or something?
I've chosen this old ML path in there. So you have a module, and module is its own world, and it can expose, opaque expose the type, so it can be used in the system in other modules, but it can only export a constructor for it. So it's not revolutionary. I don't have really dependent types as they are now used, but you have old ML trick built in.
Yeah. So it's just like a constructor constraint is like
it's a constructor constraint. Yes, but because language is so straightforward, I can use them later if we talk about verification and stuff as dependent types. Gotcha. Basically, you are not writing them as you do in Lean or Daphne, but they can be lifted to ones.
So in the native effect languages that I have looked at, it seems like most of them use handlers for their, in other words, when you call an effect, it jumps into a handler which has a continuation. So rather than a regular function call. So what are you doing for that?
I don't have handles. It's much simpler in Aver. To be honest, when I was preparing, I was thinking if I should even call them effects in Aver. And that's because they're not algebraic effects, that for sure, you cannot handle. You cannot...
There's not like a composition of
you don't have composition, exactly. I was looking for that word. You don't have compositions of effects. They are more like transitive capabilities. kind of things. So function has
It's more like
to
a way
declare...
to demarcate pure functions from impure functions.
Yes,
Gotcha.
but it's also transitive. So what I mean by that is that every function calling effectful function
Inherits
has to declare that effect, or more, like closure of sub effects of all the functions. So
there is a little bit of an algebra on that composition where if you touch a function that writes to standard out and talks to the network, then both of those get composed like additively.
Yes. And I have also these granular effects, which are much more granular than I/O in Haskell or whatever, because I have like HTTP, terminal, console, and so on, but they also have like sub effects. So you can only declare, I don't know, HTTP get or post for that function.
Yeah.
And you cannot, you can shorthand to HTTP, but compiler will nag you that, okay, that's too broad. You shouldn't be using that. You are just using get.
You can be more
but then there's some almost like security model around that you have as well, which is like, I only want to allow a get to this host or something.
But I wouldn't call it security because someone will jump on me. I think it's more of a safety feature. And I'm not saying security because you have to trust the host here, and the host language. So it's more like a safety barrier for your AI writing the code. So it doesn't it's not declaring that you can call HTTP. So if you do, it's impossible. Like it will be the type error.
Yeah.
So I'm not, I mean, when I start thinking about AI languages and realizing, because of what the AI can do, we may not need this or we may not need that we have in traditional languages. So, so I'm looking at this, and you said, all right, we're tracking the effects, but we're not using handlers. So, which may be okay because the AI is able to do more things than I know about. But what do you do with the effects that you're tracking?
We have a couple of things. So first of all, they are transitive, so they have to go to the very upperst level. So that's the first thing. So
it's like function coloring, but beyond async.
Yes,
you're tracking.
Yes.
So async was the original function color, and now you've got a rainbow of colors.
Yeah, which I don't like async because it makes the coloring, but like both ways. You have async await, and I don't like something like that. Here it's much more simple. It does one additional thing that's maybe not on topic, but it forces your code to not have many like transitive levels with the effects because it gets out of hand. So it tends
feels
to,
dirty
even
when
for AI, it feels dirty. So it makes you have this pure core, and effectful shell. And it's like, I didn't know when I was starting Aver that's the outcome, but AI on its own is like, okay, I don't like that I have 5 levels of FX transitioning, so I will just architecturally get rid of that.
Yeah.
And there is one more thing about effects in Aver, that all of the effects, they are like pre-declared by compiler. You cannot define your own at the moment. But you can record and replay. So when you run the program, you can record every effect that has happened, and it's stored in a JSON file, and you can replay that later. So that's a convenience feature.
So you can verify that you get the same results.
Yes. You can verify that the effects were fired in the same order and consumed in the same, because some of them are
presumably the same values.
Yes, our values are also stored. And there is like different levels also, that, for example, you haven't consumed all the events. Like there is more in the file than your program has
you
consumed.
Can like the diff2 runs and validate that. Yeah.
And that's an interesting approach, because like if you have an effect that is a random number generator, the programmer needs to swap in a random number generator their own that generates non-random numbers so that they can do the testing. But you're saying, well, actually all you have to do is record it, and then if you replay it,
yeah.
then the programmer doesn't need to go to all that trouble. So it simplifies that process.
Yes, and at the beginning that was the only mechanism to test effectful functions, but then I've added like verify blocks for it, and verify blocks are something in Aver that probably needs its own explaining and everything.
Okay.
So
Before we get into the verify, there's maybe another thing that's nice about having the explicit effects in the world of WASM, which maybe you've done, maybe you haven't yet, but in the world of WASI, you can expose like, okay, this particular block of functionality has these side effects, and you can express that through WASI and WASM components. And so that then the other side, that's the consumer of that thing, can decide how it wants to actually implement those pieces. So because you've already defined the side affecting pieces, you could probably create the accurate WASI view of those side affecting functions.
yeah, and I was playing with that, to be honest. I did WASI preview 1 first, but I didn't like what came out, and I'm on WASI preview 2 already, but I'm not doing this granular thing as I should be doing yet. But that's on the wish list, let's say. So yeah.
But it technically would be possible because you've
Technically
created
that
the
would be
demarcation
possible. Yeah, because right now I'm not yet exposing it as library in WASI preview.
Yeah.
Only as application. So
Yeah.
I'm like importing effects, not yet exporting. Let's say.
Gotcha. Yep.
And the different targets, we agreed that we liked the approach of having the
VM and the native and the WASM outputs. I think that's one of the things that you would be more familiar than us about, the challenges of Rust and the long compilation times. And by having the VM, it does create that short iteration loop for the AI to iterate quickly and be able to do some validation before you actually go to producing and linking a binary.
Yes, that would be really problematic for AI, and because waiting times, as you said. But I really started with interpreter, as every small language is starting. And then I've added VM, which was at the time like 100 times faster or something, and it became like the main runtime. And as you said, I'm having this code gen for different things. So there is Rust code gen, so you can basically compile to Rust. To WASM, and it's like garbage collected WASM. I started with my own memory and everything, but then it occurred to me it's like that's not needed.
Let the WASM runtime deal with all that.
Let's that be as native in all of these targets as it possibly could be. That was my assumption. And like this garbage collection is already on pretty much everything, so it's not so new.
So you had to implement your own garbage collector for the VM and for the native output. And was that given the design constraints of the language, was that an easy task or a hard task to like figure out how to implement the garbage collector well?
For Rust coding, I don't have to have garbage collection because it's handled by Rust. All those things in Rust, RC and so on. So it's like at compile time, it's checked for correctness. Yeah, in Rust. And
does it actually generate Rust code and then you let the Rust compile?
That generates like the Rust project for you with all the modules, even looking as the Aver ones, but you have to compile it later to Rust. And in VM, I didn't really go for a real garbage collection, you may argue, because I went with like memory lanes, but that's a topic on its own. Because of the simplicity of the language, there is a lot of things that are not like in every regular language. For example, it's easy for me to track when something should be, and it's immutable, as you said. So it's
Yeah.
easy for me to say, okay, so this like TCO loop has ended, and I can discard all the things
Your
that
like
are not
escape
used later.
analysis is much more
Yes.
trivial
So it's like
because of
escape analysis on
immutability.
different, on couple different levels. So like you have this very local lane of memory, then you have like TCO1, then you have one for the handoff, and you have for the handoff from the functions, so return values, etc. And you have like this stuff lives forever, pretty much, because that's how the program is done.
So how much AI were you using for the architecture, design, and implementation?
That's a really good question, and I don't have a good answer for that, because it depends at which stage of Aver. Yeah, because at the very beginning, I came up with idea pretty much on my own, and then I was ping ponging that idea with AI without even implementing it at the moment, and then I went for implementation in which probably 90% of code is written by AI. I won't be saying no. I don't want to lie to you guys. It's true, but every decision there is mine. There is no single decision that AI has made for me, and I've argued a lot for the decisions there are in Aver, because AI tends to, I don't know where it gets it from, really, maybe from the training data, that's the obvious explanation, but it tends to force you to do some stuff its way.
Going to steer you towards something it's familiar with, and what you're building is
I don't know if familiar is a good word. It's just strange. I would have to come up with specific. Oh, the specific example is it was forcing me to have like a Z3 invariants everywhere.
Yeah.
And it was arguing that's the better choice for the design. And it's like a common topic, really. And I didn't really want that, because it seems like there is another language layer at your language, which I really disliked, and so on and so on. So there is a lot of topics like that AI tends to force me to going in that direction, but I don't like.
Yeah. Yeah. So you're building Aver, the actual like parser, lecture, VM, all that kind of stuff in Rust, and is that right? And then how are you working in some kind of markdown spec for the actual like PL design, or how do you do that piece of it?
I hate markdown, so no, not markdown spec, but it's coming from usually from a long conversation with AI and like arguing for my my design decisions, really. And the only Aver code I have ever really written is like example code, how I want a specific thing to look. So I'm writing Aver code sometimes to for the design, and that's very common, to be honest. I haven't written a single program, but I've written a lot of lines to show the direction of how I want it to look.
In some ways, your spec is the like code examples. Like, this is what I want.
Yes.
The syntax to
this
look
is
like.
what I want. This is what I want. How can we achieve that? And then I have to learn a lot, because that's the first ever compiler I have written, or AI has helped me write. I wouldn't be able to do it so quickly, and probably I wouldn't have chosen Rust, because I like Rust. I can read Rust, but I find it hard to write Rust. So probably I would have chosen other language. Also.
We were curious if you had any intentions of self-hosting Aver at some point.
It's self-hosted.
It is self-hosted.
Yes, it's obscure option in there, but there is an interpreter in Aver.
So a lot of the Aver code is actually Aver today.
That's not the VM. There is, I was talking about targets, and one of them is called self-host, really. So every like run function, Aver run and Aver, or maybe only Aver run at this point. Verify is not yet ported. Is running Aver interpreter, and that interpreter right now it's going through this Rust code then. So it's really Aver to Rust compiled and attached to Cargo. So it's fun, but that was just showcase, that it could be done.
Yeah.
So what's your do you look at it in like, because we're used to languages that have standard libraries? Do you look at it that way? Do you go, oh, we'll develop a standard library, or do you look at it and say, well, no, the AI will just generate whatever it needs to generate?
Or is Rust your standard library?
No, Rust is not my standard library, and there is a really small standard library right now, and it's all the functions you need at Aver, I would say, at the moment. So it's like integer from string and stuff like that. Yeah. So
collections libraries and
collections libraries. Yeah, but to be honest, I've been pruning this standard library more than expanding it at the moment, because I had like two ways, for example, integer to string and string from integer, and I was like, well, there's two ways to do things. I should leave just one of those, and so on and so on. And
so you then like replace that duplication with your lifting functionality, and then you can like rip out the stuff that was unnecessary boilerplate, because now you have
it's just boilerplate for standard library at the moment. And I also started with map and fold on list, and I've removed it at some point. So there is no.
Yeah. What's your like collection transformation things that exist then in the standard library?
Nothing. No, and I'm not joking. I'm not joking.
Pattern match and recursion.
You pattern match. You have
you can derive everything.
Yeah, you can derive everything, pretty much everything. And you also don't have closures, so people will already like, why is that? But
because
that's also
the AI doesn't need them, I guess.
AI doesn't need them. That's a syntax sugar. And I keep explaining that to people, and people get angry about closures. I'm saying about no if statements, no loops and everything, and then closures somehow, light people up. I don't know why.
But I mean, really, all those functors on any type of data class is really just syntactic sugar for recursion and pattern matching, right? Like, you've got the
I know it makes easier for me to write code, when I'm writing code by hand. But does it make review easier? Really? Like you don't have one more function somewhere in a module, because that's what usually it saves. Just one function, which is named right now, and you can reason about what it's doing without looking at it even.
Yeah, that's the part that I keep having to rewire my brain around. It's like, does this serve humans, or does it, is it something that's essential that the machine needs, and what can we take away and still be able to maybe it's even easier or better for the machine to generate code.
I wouldn't say it's easier, because I was testing that part, and because there are other languages meant for AI, and the main purpose of those languages is to make it easier for AI, and that was not my design goal, to be honest. Maybe it happened for other reasons, but what I did, I called it design by inconvenience, really. So I'm removing all the stuff that's not necessary, but other people tried, for example, okay, this language is minimizing the number of tokens that are used by AI. So you have like one letter variables or something, or they're not named, and etc.
But then it's hard for the human to review.
Yeah, it's really hard for human to review and validate. So my assumption was, okay, AI is writing it. It doesn't need a lot of sugar. It makes everything easier for me, those targets, as you said, and everything. Language is really easy. There is no closures, not a lot of things that can go wrong. Still, it's complicated stuff, but not as complicated as regular languages, And yeah, that just happened.
And then real quick before we get on to more deeper on validation stuff, there was a few interesting tools that you provide that are in the same vein. So you can do Aver context and Aver shape, which could be like helpful for the human, but also are really helpful for the AI to just understand the structure of things, the interconnectedness of things, and give us maybe a little more detail on those pieces.
Yeah, so Aver has these non-standard functions the compiler has or commands. One of them is context, and it's really obvious when you think in introspection about it. So what the context is AI doesn't need to read all your code, or human doesn't need to read all your code. It's just it needs the context for AI. It's called context because of AI, really. And the context is like minimize view of your program. And that was really easy to do because of the design of the language design. If you have this mandatory intent everywhere with all the functions, if you have those effects in there, it's really easy to export that without the function bodies. And usually that's good enough for AI to reason about what code is doing. Yeah.
Yeah.
So I can strip all the code from it, and it's and it's still readable. And it also does this little trick in which you can say what your budget is. So, for example, give me this program for 10 kilobytes or something, because that's my window for AI I can spend.
Yeah.
Oh.
Yeah.
Or focus on specific function. That's another one. Because, for example, I want to start with this function and all its offsprings, whatever it's using. Yeah.
So you can kind of like
API
traverse
for AI.
down. Yeah.
Yes.
You can traverse down the context graph, and because the context will give you the related pieces, and so you can be like, okay, we're working here, but now we're going to switch over here and work. So now go get the context for this thing. So it's like lazy context loading as you traverse.
So you may start with like overall view of whole program, and then if you focus on specific modules or specific functions, you can dig deeper or give more budget in kilobytes if you wish.
Yeah.
And AI is doing that. I've seen it doing, like, there is Cloud Skill I've made for it, and it's using it really, really often. And I find it really funny because I think Codex was doing that, because I use Cloud Code and Codex usually, both of them. And Codex like this Aver context command so much that it's tried to use it on the Rust code of compiler. And then, okay, that's not working on Rust. It's on the Aver thing. And that was quite funny to be honest.
So what's your concurrency story?
Oh, concurrency. I really wanted to have some concurrency in Aver, that I didn't want it to poison the whole language, kind of a thing. And I think coloring like async await would be problematic. Yeah, it's a lot to reason. I don't like reading code with async await. I didn't go with effects because you can use effects for async await, but I don't have such complicated effects that like you have in Z or somewhere.
Yeah.
So I made this very simple observation that if you have a tuple with two functions, or 3 or 4, it's up to you. You can reason about if what those functions are doing is independent or not. So
like, is there any shared
state
between them or something?
Yeah, there is no shared state between them, but they might be effects.
Right.
Involved. There might be effects, and like I didn't want Aver compiler to guess for you, because sometimes you can do like 5 HTTP posts because they are safe to do. Sometimes they aren't. They have to be done in order. So it's asking you to say if those are independent ones or Those are regular ones, and they have to be in order. And you have just one gimmick at the end with exclamation mark, which is saying those are independent and can be run independent. It's more like this Haskell par that it's a hint for the compiler kind of a thing. So it can be done in any order, but it doesn't have to. And right now, only Rust CodeGen is really doing that in parallel. But yeah, that's in place. And it was really funny to wire it with the record and replay, if you can imagine. Because then you have to reason about which branch it went on and so on. So it was problematic to do, but I managed to do that. So
Nice.
so it's like it's working.
Did you go to as far as like describing the like algebraic laws of the side effects so that you could determine if something was commutative or associative or whatever, so that then you in the type system could derive the parallelization capabilities of a given side effect? Or
I was on that path, but I gave up. It's as I said, it's not always. There are languages doing that. Yeah, that's the first thing already, and they try to reason for you. Aver is not that smart. It just tells you, okay, that might be problematic for some known shapes. Yeah, for some known shapes, it can say, okay, you're doing this bright and read here, and that might not be what you want, but it doesn't stop you from doing that at this point. I didn't want when I have to review that code, that's one thing you have to really dig into. What those functions independent product, independent tuple thing are doing. That's one thing you have to focus on reviewing right now.
So it's not going to prevent you from having some race condition foot gun, but it does give you the ability to specify things such that if you've indicated that this is a place that I need to be careful of a race condition, then the compiler is going to help you validate that.
Yes, it will say that might be problematic, but it won't stop you from doing that, because it occurred to me that there might be valid scenarios, and you're never smarter than someone writing the code. Yeah.
Well, and oftentimes when you're talking to an external system, it's really up to that external system what its constraints are. You know, it's like, is this request item potent? Depends on how the server defines it. You know.
Yes.
You use the word shape a lot, and I think you have explored this idea that pieces of code have shapes.
Yes, I really like that word, and to be honest, I'm not sure if it's a good one in English. If you hear that as a language designer, because it occurred to me while reading the Aver code that the code, or maybe I'll start with the anecdote from Python, because I work also with Python a lot, and a lot of Python code is kind of shapeless to me at the moment. And what I mean by that, there is no strong core. Like I don't immediately see what it's doing.
You can't look at it and see, that's a triangle, that's a square, that's a
that's a triangle, that's a square. Okay, they're composed here and there, and maybe something is ductile or whatever, and I have to reason a lot. But when I'm looking at Aver code, it occurred to me, okay, those functions are usually this or that. So this function is match. Yeah, this function is recurrency. Those are, this one is recurrent with the other one. And it's obvious when you're looking at the code because of the language limitations again. So I've explored this idea of shape a lot. And as you asked before, there is even command for that called Aver shape, which tries to, it's not really guessing, I would say. It's seeing that this function is only doing a single match in here, yeah? Or this function is doing like the pipeline thing in it.
Yeah.
So like checking something for error, checking another thing for error, and if it's okay, returning something, yeah? Or other stuff. Like I think I have I initially had like 9 or 10 such shapes, but I went with 14 at the moment. And they are classified. And I also made this kind of tiny discovery of mine that when looking at the whole modules or folders, you can reason about what architectural layer that code is by the shape of like histogram of shapes of the functions.
Yeah.
So for example, I have this pure call-rich domain stuff. So there won't be a lot of effects in there. Yeah, there won't be. There will be a lot of math. There will be some recursion in it, but not a lot of effects, for example, and so on, so on. So and here the guessing part comes in, that you can say, okay, this code statistically should be this layer of your program, like domain or something. You can redefine what those are. So I'm not forcing my numbers on you. You can redefine what those should be for your own program. But you can basically have this additional layer of checking if the shape of each layer is what it should probably be.
Yeah. And so some examples of those shapes are like, you can have a transformation layer, would be a typical kind of architectural layer, or you can have a business logic layer. And by looking at the shape of something in Aver, you can make some statistical assumptions of what that architectural layer or shape is.
Yes, exactly. And I've started with that, and then it occurred to me that there is one more layer to this shape, that sometimes there is two functions which are like intertwined. For example, this function is only serving as the entry point for the other one. So I have like for example, Fibonacci one, real one, which does like the recursion in it, and I have the other one which is just guarding the input, for example. And I'm also kind of explore that idea right now a lot.
Yeah. Huh. Okay, so let's talk about the validation side, since that's, I think, one of the things that really differentiates Aver is the ability to define not just tests, like, so we've got types and we've got functions with explicit inputs and outputs and effects, but then we need to be able to validate that our intent was actually fulfilled. And so there's layers to that. You can write a kind of more imperative assertion style test for a given function, but then you can also write a proof using, and underneath the covers you can export or use Lean or Daphne. So yeah, give us a little more on that whole piece of the machinery.
Yeah, I've started with really simple idea, as always. So the really simple idea is, I want tests collocated with the code. And that was meant to serve a similar purpose as this intent. Yeah, so something I don't really have to look at the body of the function. Sometimes it's easier to look at examples. Yeah, you have them at you have the function, and the Aver format is putting the verify functions below just below the function, so I can see what it's doing on input and output side. And it was meant only for pure functions. But then I realized that there is more to it. And there could be possibly more to it. So you have this example ones, as you said. So it's the simple verify, but you can also have like verify law. I call it law, and then it's more like there is Python thing called crosshair. But there is a lot of it's a bit like property testing. It seems on the surface a bit like a property testing. So you have like a given integer being 1, 2, 3, or 1,000, yeah, or integers from 1 to 10,000 or something. These functions, and you can also have guards in there, like given the one integer, given the other one, and when one is larger than the other one, or something like that. I'm invoking that function and knowing something about the output, yeah? And you can define a lot of laws that way, really. So, I don't know, A plus B is equal to B plus A, and so on and so on. So a lot of functions could be, a lot of laws could be could be explained that way. It's a very simple way, to be honest. It's nothing, nothing
And that's
substantial.
different than. So while the syntax looks similar to property-based testing, you actually can derive a proof essentially from
Yes,
what
I
looks like
derived.
testing.
There are two more levels to that, because at the Aver verify, so what is running VM or WASM, I'm just checking the examples. That's it. So it's the fast and easy one, and then I.
Real quick, so in the VM, you essentially do like property-based testing with
in VM is just property-based testing, nothing fancy. But then there is hostile option to VM to verify, which does substitute those values for you.
Mm-hmm.
So, for example, you said that's integer and you provided some of them, and here are the nasty integers for you. So I'm checking your law against nasty stuff, and that also happens for the effects. So, for example, because you can stub effects in those functions also when you verify effectful functions, you are just writing the function which is stubbing it. So, for example, when I'm doing the disk read text, it returns this or that. And
so
the
that is a little more like
will...
the effect handlers. Like, so in the verify blocks, you can create the mock implementation of what the effect
stub
is
or mock,
do.
But and you can use those, like in verify, those example simple ones, and in loss, and in loss only in loss they are lifted. I would say only in loss in hostile mode. I'm substituting it for bad things again. So your disk is burning, clocks going other side, like rewinding clocks and so on, or random always returning one, and so on. And it says, okay, that law of yours might not be a real law. You might be missing guard, or you might just want to provide examples, and those are not examples. You said it's something more than that. So that's this intermediate level of checking. And there is one more, which is exporting it's like a code gen, but there is a separate command for that, which is Aver proof. And Aver proof is doing a Daphne or Lean project for you out of Aver code. And then in Daphne or Lean, if you have example verify, which are not laws, it's just by example, which both Daphne and Lean can easily do. But if you have the slow ones, they are again lifted, and they're lifted to for all the integers proofs. And about the effects, those are also lifted, but they're lifted through oracle functions, if you're familiar with the term. So it means that for every possible function of clock, which might be returning whatever the clock is returning, that holds true.
So in your lift to a actual proof, do you have to use AI to actually derive the proof, or can you do it totally deterministically?
That's a really good question, and I was exploring that idea too. So right now, no, I'm not using AI in there. I'm again exploring the shapes of the functions. I wouldn't say it closes everything, because it doesn't. But a lot of stuff is closed for you. A lot of proofs can be closed. So I'm again identifying shapes of the laws and shapes of the functions that are tested, and I can say, okay, this function is a good example is guarded. Like I have Fibonacci, and Fibonacci is guarded by something, and then in Lean, this guard is lifted to subtype, for example, and that's like a Lean, what Lean person would write in there, or the opaque natural in module, which only has the constructor that is guarding it. It's also lifted to this subtype. So yeah, it's doing a lot of tricks like that, and it's closing a lot of proofs. I wouldn't say that's ideal. So some of the proofs are left for you to prove with AI help, maybe, or I will someday find a way to close all the gaps. Possibly no, not never. But
is there any way for the Aver compiler outside of AI to know if something is closed or not? If a proof is closed, like
because right now I've added this pretty recently. I've added that it's not only like transpiling to Lean or Daphne, but also running it. And when it runs it, it can check, okay, I've closed this match.
The Lean or Daphne can do the analysis on whether it's closed.
It's run against Lean or Daphne. And I'm also exploring the idea right now of, because some projects are doing the thing in which like they export to Lean or Daphne and they try different strategies in there and see what closes. I don't like that idea that much because I'm like, the code is in Aver is so simple. I usually can reason about it better than just guessing. But some Daphne stuff, you have like the fuel budget in there, and sometimes just raising this budget helps you close the proof. So maybe I will add something like auto adjust or auto check and try different strategies.
And so then in your skills that you have for people that are using Aver, do you say like, okay, you're going to, do this and write this code and you're going to use this command to like check. And then, once you get through that and you're good, then you're going to run, I don't know what the next step would be, but ultimately get to like actually proof. And so like, does your skill kind of describe the actual workflow that the AI should use to like iterate quickly and then more completely, as it moves kind of out? Or how do you?
It describes all the tooling at the moment, but to be honest, I didn't want to switch everyone to proofs and to formal verification, because that's my honest opinion. I don't think every single program on earth needs to be formally verified. It's opt-in. So if you want it, you can use that. It makes it easier for you. You may just like the very core, a very core function of yours. Maybe that's needed, or very core module that's needed to be checked. But
it's still up to the developer to decide when they want to add a law into.
Basically, that law is magic word which does all the lifting and proving. But
so probably generally if somebody's working on kind of a algorithmic piece of code that the algorithm needs to work verifiably and consistently, then you would add a law. But if you're reading records from a database or something like that, the law is not super helpful in that case.
There might be people arguing that's the ultimate goal, and I also added these effects in proofs as those oracles and so on. But usually that's not what you're proving with Lean. That's not the part that people tend to prove, because it's
so the skill doesn't say this is the one workflow you must use on any piece of code that you're using. It describes here's the tools that are available, but then you still lean on the developer choosing when they want to add a law, and then once a law exists in the code, then the skill is going to tell it how to actually execute the proof and stuff. So,
or AI, if it decides to want the proofs, which probably won't on its own, because it's more complicated than those really simple example verify blocks.
Nice. Are there any other major features of Aver that we haven't gone over?
I think we covered pretty much all the interesting one. Maybe one more that also in those verify blocks you can trace effects. So if you add a word trace in there, you might say, okay, this fired in this particular branch, for example, of this independent products. Or I had 5 HTTP GET calls or something like that.
Huh.
Yeah.
What are you working on now? What are your plans going forward with the project?
To be honest, I'm ripping apart the compiler right now.
Oh.
Re-architecting.
And yeah, because I think I possibly made some technical debt in there, and I figured that out when working on recently on the proof infrastructure, and I was like, okay, maybe that's finally the moment I have like the typed HER, that's or stuff like that. So yeah, I'm ripping the compiler right now.
So for now,
Reworking it from the ground,
re-architecting.
to be honest.
Yeah.
Yeah.
Um, and then, yeah, what's after you get the new architecture in place, are there other kind of big ideas you're looking to tackle, or anything that on the kind of language feature side that you're thinking about?
Yeah, I'm thinking about couple. One arm of this project is always the proving side, because that's interesting. I find it really interesting to try to close all those gaps that exist. So I have a lot of ideas on how to do that, and I'm even right now implementing this additional compiler internal layer of proof intermediate representation kind of a thing, because it's different than what you need for transpilation to Rust or whatever. It's different.
Yeah.
You have different things to reason about. So that's something I'm working on right now.
Is
But I
it so on
don't.
that one,
Mhm.
real quick? So this is maybe moving some of the validation closer to the time of the AI writing code, so that it can get more feedback more quickly as it's doing
Yes,
its
because
iteration loops.
yeah, also the compiler like works in that way that you can explains, like there is a command to explain specific passes of the compiler. So you can, AI or you can reason about what this Aver code is lifted, reinterpreted to, and so on.
Yeah.
So, okay, for example, for the proving, I've seen this type of yours, which seems to be not dependent, the subtype in Lean, or could become subtype in Lean or something like that. So it's easier for you to reason about how the stuff is happening, really.
Yeah. It's like I've wondered at what point our AI will have like AI integrated compilers that would almost like expose an AST of the compiled code to the AI instead of the actual textual representation. And that's like, maybe something in the type system area, but then you are saying let's do something similar to that, but go into more of the validation realm as well, beyond just basic types.
Yeah, that's possible, but also, to be honest, when I was checking something like that, because I was checking different ideas of how Aver could potentially look, and it seemed to me like on the generation side, current AI, current LLMs are better used to have code as we know it. Yeah.
Yeah.
So it's not some fancy higher AST or interpretation or whatever of it.
Yeah. Yeah, I guess they're
It just
trained
seems to.
on natural language, and
Yes.
so code is more of a natural language to it than an AST is.
Yes, still it is.
Yeah.
Maybe that might not be true in near future. We don't know about it. So the whole thing I'm building is a huge bet about capabilities and what's happening with AI and future. But yeah, I'm seeing it more like a funny experiment of mine, to be honest.
Are you tracking the other languages that are coming out of this?
I've seen a bunch of them. close to 30 like at the moment or something.
Wow.
Yes, there's so many of them, and there is a very good website which right now tries to track them.
Oh.
Agent Languages Dev
Okay.
or something. Yeah,
Huh.
it's
I'll
by
check it out.
creator of one of them. so you should check. And like usually they don't have a huge following, and it's the guy even split them into 3 different categories, let's say. And I've landed in verification one, so the languages which focus on verification, and there are ones that are focused more on orchestration for AI, kind of a thing. So
And then
they
some
want
that are
to
more
make
focused on like token efficiency.
yeah, and that like the syntactic or something
Yeah.
camp as the guy has described it. And I would say Aver lands in both syntactic and verification for AI. But there are different things you can optimize for, and I find it quite funny to look at the other languages. They feel like a mirror. Very often I look at them at the mirror. There is theme in there going on, which I think that's AI forcing people to do, which is having all the requires and ensures Z3 blocks everywhere. So
Yeah.
maybe that's forced by AI. I'm not sure. Maybe people are coming at this design, everyone as a separate
Yeah, because
person.
that, even though that's been pushed for a long time, it's not something that programmers have been commonly doing. So the fact that the AI is doing it is interesting.
Yeah.
Maybe if you ask, specific questions, specific enough, it comes with this answer at the moment.
Yeah.
That may change in a couple months. Yeah, we don't know. So that's kind of interesting. I think AI is steering people building those languages a lot, including me. I'm not saying I'm fully immune. Yeah.
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 Well, and we have such a great opportunity to do experiments, and then I'm sure that many people are doing these experiments and probably uncovering common truths or something as they've done the experiments. So
effects are one of the common truths.
Exactly.
Seems like
it occurs. Basically, pretty much all of those languages have some form of the effects.
Yeah.
Sometimes much more complicated than Aver's one. Yeah.
One thing I'm curious about your perspective on is if you write a function definition, just the like inputs and outputs and effects and the intent string, and then you write a test or a law for that function, how valuable is the body of that function, the actual implementation? Like, does it do as a human, do I even care if I've got the inputs and outputs and intent and effects and the tests, the verifications of that function? Like, do I ever need to care about how the AI came up with the actual body of that thing?
I really love the question. That's the first thing, because I was thinking about it a lot. Because one may argue that you don't need a body at this moment. Like, body is redundant. It's described, it has the test, so let AI write the body. I don't agree at the moment. I think that body is there, first of all, saving us a proof of what was done, what was achieved, and I love the shape of it. I can reason about the things from the shape of this body. Maybe you, as someone reviewing that, when I'm looking at Aver's code, I'm usually skipping the bodies, to be honest. They are not the most interesting part, but I can see the shapes of them pretty easily. So I don't need to go deeper into fifth line or somewhere. I already seen it's the match one. I like pattern matched it just by eyeballing it. And I think that's really something. And I find it only after I've done all the language, all the design decisions behind it, and then looking at the code, I was like, why did that happened? That's really something. That's really something interesting, and it all comes from what I've stripped from the language. And AI, I think it's having more difficult time writing in Aver because it has to to fit into those shapes. Yeah.
Yeah.
So I don't think it's easier for AI. I would say it's a little bit trickier than in regular language, but then it forces it to have a very distinct shapes in the code, because someone might also argue that it's the same thing written 3 times, because you have the intent, you have the body, and you have the verify block. At the very beginning, I was thinking, okay, that's something that we can catch AI by hand, saying, okay, you have to say it 3 times for it to be more true, kind of a thing. So you won't imagine it, or I don't know how to describe it, but it's like you have to write the very same thing 3 times, so it's like more true-ish, more true. Like
I guess there's a triangle of validation that all comes together so that you can have confidence in your code. Just as an example, I've seen jokes about AI creating, you say like, create a random function, and it's like if input is 1, then this, and you see like all these like if then statements where the AI like only covered 6 of the cases or whatever, and maybe your like property based testing or law based testing would catch that kind of thing, but it's like the AI like clearly like took a shortcut here, and instead of like coming up with the general implementation of this thing, it did the lazy way. And being able to actually look at the body and be like, oh yeah, like that body actually does match my intent. It's not just taking the shortcut route, is probably an important piece of the verification system. And then probably the iterative loop to get there as well, is like often you don't know how to fully specify something until you've like iterated a few times on the body. And so there's probably also this like iteration that's enabled by having all 3 instead of having the body be hidden.
Yeah, but there's one more interesting thing I would add to what you said, because one thing is I think about AI as being cooperative with Aver, because I can't guarantee that the intent that's written and the verify blocks that are written are what you really meant.
Yeah.
Like it's not treating AI as I don't know, a spy trying to sneak something bad or stuff like that, because I can't assure that. I can't think about a way to even prove. Like proof is proving whatever was written there to prove. You have to read what's trying to be proved. You don't assume it's true. You can verify that it's always true. Like that's not verifying anything. So you still have to read that and stamp it. It becomes like legalese in Python, but you still have to do that. I'm not saying it's not meant to be read.
It wasn't more than a few months ago I asked the AI to write a test for me, and it was a test against a particularly complex bit of code, and it tried, and then it ultimately just landed on assert true, and that was the test.
And I've seen that in AI languages, that you have for example these Z3 ensures blocks somewhere there. They are usually at the function, close to function definition, so like effects in Aver, and there is ensures true. So that's like, it's okay, it doesn't ensure anything, but it's there serving us as, I don't know how to describe that even. As proof of nothing.
Proof of nothing. Yeah, exactly. And so I think that is the challenge with where the human is needed in the verification loop, is that we express intent, and then it's up to us to validate that our intent was actually fulfilled by the written body, the type signatures, and the tests and verification and laws and all that we write. So it's the human is responsible for doing that. We bring the trust that our intention was actually achieved. And so the language needs to enable us as humans to provide that validation of intent.
Language can do as much as being easy to read, not hide stuff as Aver is doing, because I also think closures and all the syntax sugar might be hiding it. You have to reason more. Maybe you have to read less, but you have to reason more, kind of a thing. And also by the language design, you can make some errors impossible to express in a language. That's what I was initially exploring a lot. So, decisions like there are no exceptions, obvious ones right now. With the monads returning stuff and so on. So you can prevent, like matches have to be exhaustive. I don't have ifs because match is exhaustive and it's checked for exhaustiveness, for example. So there is things you can do and there are things you cannot do. You cannot assure intent was expressed as you wanted it to be.
Yep. Right. Awesome. Well, thank you so much for your work on Aver, and love to see all the great things that you've brought out with that, with effects and laws and proofs and great tooling for the AI and human readability. And I think it's super exciting to see what you're building. So thank you for all the work you do on it.